Hello everyone, welcome back to our Arduino course. Today I'm going to show you what is ultrasonic sensor, its functionalities, and how we can read data from this sensor and show this data on serial monitor in Arduino. Also, I'm going to write a simple code for a simple application which is incremental alarm. So what is ultrasonic sensor? Ultrasonic sensor is an electronic device that measures the distance between the sensor itself and any object on the front of it by emitting ultrasonic sound waves. It has transducer. Transducer means transmitter and receiver. Here we have the T letter, which is coming from transmitter, and R from receiver. Here is the transmitter and this is the receiver. The transmitter is going to send ultrasonic pulses. When these ultrasonic pulses hit a wall or any object in front of the sensor, they will bounce back and the receiver will receive these pulses. It has 4 pins: VCC, trig, echo, GND. We are going to connect VCC to the 5V of Arduino, GND to the ground of Arduino. So how does this sensor work? First, we are going to send a pulse with 5V 10 microseconds from Arduino to the trig pin. Since we send this pulse on the trig pin, the transmitter will start sending or transmitting 8 ultrasonic pulses with a frequency 40 kHz. These pulses, when they hit a wall or any object in front of the sensor, they will bounce back and the receiver will receive these pulses, and the echo pin will output a pulse of 150 microsecond to 25 millisecond. The width of this pulse is used to calculate the distance, but we have to know that the echo pulse will time out after 38 milliseconds if there is no object detected or if there is no object in front of the sensor. As you can see in this demo, when we send the 10 microsecond pulse on the trigger pin, the transmitter will send 8 ultrasonic pulses and the echo pin here outputs 38 milliseconds. It means there is no object detected in front of the sensor. 38 milliseconds, no object detected. So from the echo pin or from the width of the pulse, which is coming from the echo pin, we are going to determine or calculate the distance. Here another demo with object. We send the pulse, the transmitter sending 8 ultrasonic pulses, and here we have an object and the width is 500 microseconds. Transmitter sending pulses. These pulses bounce back to the receiver and the echo pin gives me 5 microseconds. This is an example, 5 microseconds. The range of this pulse is from 150 microseconds to 25 milliseconds. Depends how close this object to the sensor. Now we are going to calculate the distance. How we can calculate the distance? The distance equal time times speed of sound. Why speed of sound? What is the time? As we know, ultrasonic signals travel at the speed of sound, which is 343 meters per second. These pulses travel at the speed of sound, which is 343 meters per second. And what is the time? We need only the time from the object till we receive them on the receiver, because the Arduino is going to give me the time since we send them from the transmitter till we receive them on the receiver, and this is wrong. We need only the time since the pulses hit the wall or bounce back from the wall or the object till we receive them on the receiver. So we need only the time from the object to the receiver. How we can do that? Just divide the measured time on Arduino by 2, because Arduino is going to give me the time since we send them from the transmitter till we receive them on receiver, and we need only half of this time, which is from the object till receiver, till we receive them on receiver, till we receive, I mean the pulses. So the speed of sound, as I said, 343 meters per second equal, I'm going to convert from meter per second to centimeter per microsecond. Why? Because why microsecond? Because Arduino is measuring the time by microseconds, and I need the distance in centimeter, not meters. I need the measurement unit in centimeter, not meter. So that's why I multiplied 343 by 10 power minus 4. I converted to centimeter per microsecond. It's equal 0.0343 centimeter per second. Here the time in microsecond, it's coming from Arduino. The speed of sound we already know. Here it is, it's in centimeter per second, and the distance, it's unknown in centimeter, but we are going to calculate it from Arduino. Here we have example. For example, let's go back to the previous demo. Here the echo pin gave me 500 microseconds. Let's do this example. For example, we are going to do this example, which is 500 microseconds measured by Arduino. This is the time which Arduino gave me. It's an example. Distance equal time multiplied by speed of sound. Distance equal 500 divided by 2, because I need only the return trip, only the time from the object till the receiver. 500 divided by 2, which is 250, multiplied by 0.0343, which is the speed of sound, but in centimeter per microsecond. And this time in microsecond, Arduino gave me this time per microsecond in microseconds. So the distance equal 8.575 centimeter. Here is our first example, display on serial monitor. I'm going to connect ultrasonic sensor to Arduino Uno and show the distance on serial monitor. As I said, I connected VCC to the 5 volt of Arduino, GND to the ground of Arduino. Trigger pin, I connected the trigger pin to the pin number 10 in Arduino, and echo pin to pin number 9 in Arduino. Please note that trigger pin or pin number 10 in Arduino, I have to define it as output, because I already told you I'm going to send a pulse with 5 volt 10 microseconds from Arduino to the trig pin. Then, as I said, the transmitter will start sending the ultrasonic pulses. When they bounce back from any object, the receiver will receive them, and I will receive the width of the pulse, which is on echo pin. So I have to define pin number 9 as input, because I have to read the pulse which is coming from echo pin. So pin number 10 as output and pin number 9 as input. Here is our code. I define trig bin as pin number 10 in Arduino and echo pin as pin number 9 in Arduino. Here I define two variables, duration and distance. The data type is a float. Float, it's a floating point variables. This kind of data type can contain decimal point numbers. The first variable defines the duration of the signal we get back from the sensor, and the second one is the distance. Inside the void setup, here serial.begin 9600. Here we are setting the serial monitor at 9600 baud rate. This is the baud rate. So we have to choose the same number at the serial monitor. Bin mode, trig bin as output. Here I'm defining the bin number 10, which is trig bin, as output, and bin number 9, which is echo bin, as input. As I said, trig bin, we are going to send a pulse with 10 microseconds to the sensor, to the trig bin, and echo bin we are going to receive. That's why I define it as input. Echo bin as input and trig bin as output. Void loop. In the void loop here, first we are going to send the pulse with 10 microseconds to the trig bin. First, digital write trig bin low, delay microseconds 2. Here, just to make sure the pulse starts from the low level. So just to make sure it's in the low level. Then here, digital write trig bin high. Here I started sending the high level of the pulse. For then delay microseconds 10 microseconds. Here I'm sending the 5 volt for 10 microseconds, then digital write trig bin low, then the pulse getting back to the low level. So this is sending for sending the pulse for 10 microseconds, and just here just to make sure this digital write trig bin low for 2 microseconds. This is just to make sure the pulse starts from the low level, then sending the 5 volt for 10 microseconds and the pulse going back to the low level. Duration equal pulse in echo pin high. This instruction just to measure the duration of the pulse which we are getting back, or which we are getting from the echo pin. So pulse in, it's an Arduino command or an Arduino instruction that measure the duration of a pulse. So it has two parameters: echo pin, which is pin number, here number 9, echo pin, and high, we are going to measure the high level of the pulse, because pulse in, it can measure the high level and low level. In our case, we are going to measure the high level, which is the width of the pulse in the high level. Calculate distance. As you know, the speed. Here we are calculating the distance equal duration divided by 2. Here we already calculated we already measured the duration in microseconds. As I said, we divided by 2. We need only the return trip. The time is only in the return trip, multiplied by 0.0343, and this is the speed of the sound in centimeter per microseconds. Now we are going to display the distance on the serial monitor. Serial.print distance equal, here distance between two semicolons. It means this is string. First I'm going to show distance equal, then I will show the serial.print distance. Here, this is the distance. It's the value of the distance, which is this one. Then I'm going to print centimeter after the value of distance. Delay for 200 milliseconds. As you can see here, there is no microseconds after delay. So this value in milliseconds. Delay 200 milliseconds. So I'm going to read the distance or to calculate the distance every 200 milliseconds. And this is our code. So let's connect our Arduino. I already connected Arduino Uno. I'm using Arduino Uno, COM number 4. Here we have this icon on the corner, which is the serial monitor. Just click on it. And as you can see here, 9,600. You have to set this value as same as in your code. In the serial.begin 9,600. You can't change it. If you change it from the serial monitor, you have to change it in void setup too. So here I'm reading now the distance. As you can see, the distance is almost 165 centimeters. And this is the distance between the sensor and the wall in my room. Here is our ultrasonic sensor. It has a transducer, transmitter, and receiver. It has 4 pins: VCC, trigger, echo, and GND. And this is from the other side. Just let me show you how I connected between the sensor and Arduino Uno. As you can see here, I connected the 5 volt from Arduino to the VCC of the sensor. The orange wire is connected between the GND from both of them. I connected the trigger pin from the sensor to the pin number 10, and the echo pin is connected to pin number 9. Now the distance between the sensor and my hand is almost 15 centimeters. Now I'm going to move my hand close to the sensor. As you can see, the distance is decreasing. Now it's 12, 11, 10 centimeter, 9 centimeter, 8, 7, 6, 5. Okay, let me move my hand away from the sensor. It started increasing. Now 13, 15, 18, 20. Yeah. Here is our second application, which is incremental alarm. It's similar to the first scheme, but the difference here is I added this alarm. What is this? It's we call it buzzer or alarm. So it's a device that gives alarm. It has 2 leads. The black one is negative or GND, and the red one is positive. I connected the positive to pin number 2 in Arduino. So how our application is going to work? So when I move my hand closer to the ultrasonic sensor, the alarm or the buzzer will start giving a quick alert. When I move my hand away from the sensor, the alert slows down. Let's go to the code. It's same to the previous code. I just added these 3 things, which is define the pose as pin number 2, define the pose as output, and I added this while loop. So why I added this while loop? Let me explain it. The condition here, distance, if distance less than or equal 30 centimeters, which means the distance, if the distance less than 30 centimeters, I said turn on the alarm for a delay, for delay, which is distance multiplied by 5. Then turn off this buzzer for a period of time, which is distance multiplied by 10. Then here I added a break. What do I mean a break? Break will break the loop, so the compiler will not keep going inside this while loop. So I want to do this procedure only for one time. Then break means break this loop and do the procedure which is inside the void loop again. Will compiler do this procedure, will come to the while loop, will check the condition, which is if distance less than or equal 30 centimeters, the compiler will do this procedure. Otherwise, if the distance not less than or equals 30 centimeters, this procedure will not be applied or will not be active. When my hand is close to the sensor and the distance is 30 or less than 30 centimeters, the alarm will start giving an alert as same as I did here with this delay of time. This is the alarm, or we call it buzzer. It has two pins, positive and negative. The long lead is positive and the short one is negative. So I'm going to connect it to the Arduino now, and I will show you how it works. Now I connected the buzzer to the Arduino Uno. As you can see, I added the green wire which is connected between the positive of the buzzer and pin number 2 in Arduino. And the negative of the buzzer is connected to the orange wire, which is the GND. When I move my hand close to the sensor, it gives a quick alert, and if I move my hand away, the alert slows down. This is everything for today. Thank you for watching, and don't forget to subscribe on my channel. See you in the next video. Bye for now.